Hi guys, welcome back to my channel. Now let me quickly show you how to solve this viral and tricky exponential equation. Alright, so are we using algebra manipulations? No, we are not using this. Are we using logarithm? No. Alright, are we using Lambert W function? Yes. So we are using Lambert W function to solve this tricky exponential equation. Now let me show you how we can quickly do that. Solution. All right, so we are going to use this identity that says if we have a raised to power b, it gives you exponential raised to power b ln a. All right, so this is the identity we are going to use for this side. And that means when we have 2 raised to power x equals to x raised to power 3, all right, this. Then another way to write this is we're writing it as e raised to power x ln 2. Okay, we use this identity to have this everything equals to x raised to power 3. All right, so from there we can take the cube root of both sides. All right, so we take the cube root of both sides, and that means that we have e raised to power x ln 2. Then we take the cube root of this side, which is same thing as 1 over 3. Also, we take the cube root of this side, so we have x raised to power 3, then raised to power 1 over 3. Okay, that's the cube root. So the cube roots cancel the cube, and then we have this. Now, another way to write this is we can write it as exponential raised to power ln 2 divided by 3, and the x can come out here. All right, this is the same thing as this. Everything equals to, we have x raised to power 1 left. Now, let's divide both sides by what we have here. We want to divide both sides by exponential raised to power ln 2 over 3, then x. So I will divide this side by this. We have exponential ln 2 divided by 3, then x. Also divide this side by this. Right, ln 2 divided by 3x. Then this divided by this, I'm having 1 left, so we have 1 equals to. Now another way to write this, since this is the reciprocal, if you have 1 over y, you can write it as y raised to power minus 1, and that's what we are writing here. So we have this x, then this will become exponential minus multiplied by this power, which is ln 2 over 3, then times x. All right, so you know that Lambert W function solves the equations of this form, y e raised to power y equals to k. All right, so it solves the equation of this form, and then by the time you have the answer, then this becomes y equals to wk. Okay, so this is when we introduce Lambert W function. All right, so we are going to write this in form of this. We are going to make this look exactly like this. And then what do? We multiply both sides by minus ln 2 over 3. Okay, so then let me write it. We multiply both sides by minus ln 2 over 3. That is what I have in this place. And then by the time we do that, we have minus ln 2 over 3. Then we have x raised to power minus ln 2 over 3. Then we also multiply this side, which is this side. We also multiply this side by minus ln 2 over 3. And that is 1 times that will give us minus ln 2 over 3. Okay. All right, now we can say let's use y, let y equals to minus ln 2 over 3x. Okay, so now it means that minus ln 2 over 3x that we have here, we also have it here as power. So let y equals to that, and then that will give us y for this. Then we have e, then this is also y raised to power y equals to what we have in this place. minus ln 2 over 3. Now, by definition, okay, let me write that. By definition of Lambert W function, I said it the other time that it becomes y equals to w, and then the k is what we have here, which is this. So we have ln 2 over 3. Okay, so this is what this becomes by definition of Lambert W function. All right, so we can now undo the substitution. We can bring back what our y is. Remember that I said let our y equals to this. All right, so we can bring it back. So by the time we bring it back, this y is minus ln 2 over 3x, then equals to this, equals to w minus ln 2 over 3. Okay, this becomes this. So for us to find x, we have to divide both sides by this. So we are dividing both sides by minus ln 2 over 3. Okay, so we also divide this side by minus ln 2 over 3. So minus ln 2 over 3 cancel minus ln 2 over 3. We have only x. So we have x to be equals to, now you can bring this up, it's division. By the time it comes up, it becomes minus 3 over ln 2, then multiply by the whole of this, w, then minus ln 2 over 3. Okay, so this is the same thing as this. All right, so now these constants, remember these represent the constants. The constant minus ln 2 over 3 is equivalent to, when you get ln 2 divided by 3, it's going to give us 0.231049. Then we have the negative sign. Okay, now this is what we have as the constant. Then this constant, this number lies between minus 1 and 0. Okay, so because it lies between minus 1 and 0, then it means our w, okay, so I will just say therefore w has two real numbers or real values. Okay, so because this lies between 0 and 1, then we expect our w to have two real numbers. Okay, now what are the real numbers? We have, okay, 0 of the constants, and then we have w minus 1 of the constants. Okay, so these are the two values, the real values of w. Then for us to get x, remember that we say that x is equals to this, all right, but then we're having this to be either 0 and minus 1 or minus 1. Then that means the value of x, we have x1. Our x1 will be minus 3 over ln 2, then wo of the constants, and our x2 now will be minus 3 over ln 2, then this is 1, sorry, this will be 1, minus 1. This will be minus 1 minus ln 2 over 3. Okay, so we have is between 0 and minus 1. All right, so now we know what this is already, so we can just say our x1 now is equals to minus 3 ln 2, then the whole of this will give us minus 0.317338, something around that figure. Okay, and then by the time we multiply this with this, here we do ln 2, then we do 3 over ln 2 multiplied by this, it will be positive. Minus times minus will give us plus. That means that our x1 will be approximately 1.373467, okay, around that figure. That is our x1. Then let's look at our x2. Our x2 is going to be minus 3 ln 2, and then don't forget we have it to be minus 1 of the constants. Okay, let me write that again. All right, so then we have our x2 to be minus 3 ln 2. Then the whole of this is minus 2.29650. Right, so by the time we multiply it with that, so it means our S2 is approximately 9.939535. All right, so we have two answers already. We have our x1 and our x2. Therefore, our x1 is approximately 1.373467, and our x2 is approximately 9.939535. So it means x can be this or x can be that. We can check. All right, let's do a quick check. Let's do a quick check of our answers. Right, so now we have x to be 1.373467. Don't forget our equation. Our initial equation is we have x raised to the power 3 equals to 2 raised to the power x. Then what is our x? Our x is this. We have 1.373467 raised to the power 3 equals to, then we have 2. What is our x? 1.373467. All right, so now this will give us approximately 2.6. All right, and if you also look at this, it will give us approximately 2.6. So that means that here the value of x is valid. Okay, for the second value of x, then let's look at that as well. You know, we have our equation to be x raised to the power 3 equals to 2 raised to the power x. Then the second value of x is 9.939535 raised to the power 3 equals to 2 raised to the power dx, which is 9.939535. Okay, now this is approximately 982.9, and this also is approximately 982.9. Okay, that shows that the value of x here is also valid. So the two values of x that we got are actually valid solutions. Now let's do something very similar to this. Now let's try this. Okay, so we have 3 raised to the power x equals to x raised to the power 2. Okay, so let's find x. All right, so you know that algebraic manipulations will not work, and also logarithm. Okay, but I want us to try Lambert W function to find the value of x. Thanks guys for watching this video. Drop your answer under the comment section. Don't forget to like this video, share it to friends and families, and also if you have not subscribed to this channel, please and please do subscribe. See you in my next video.